Hi, everybody. This is Aaron Schwartz, one of the secondary math specialists with Montgomery County Public Schools. In this video, we're looking at writing quadratic expressions from tile diagrams, a video that I'm calling Tile and Error. In Unit 4, Topic 1, students learn to model quadratic relationships with expressions by exploring patterns and connecting to area. Key concepts include quadratic functions can model changing areas. One of the helpful skills that students have learned already is that multiplication can be modeled as an array of length versus width. This is done extensively in elementary school, and it's also reinforced in Math 6 when students look at the quotient of fractions. Algebraic expressions can be used as models of patterns. This is done in IM, Math 8, and Algebra 1. Let's go from some areas to expressions. Here we have a tile diagram. This is a quadratic, which I'm just going to state because it's not relevant to prove that it's a quadratic at the moment. At stage 1, we have 2 squares. At stage 2, we have 6 squares. Stage 3, we have 12 squares, and so on. One of the important questions is to ask students how they perceive the squares and the rectangles changing from stage to stage. Some students may see an extra column and an extra row each time. Other students may see it as a square with an extra row on top. These are both important ways of looking at the diagram. We're going to connect to each of them in a minute. First, we're going to look at making a chart because organizing the information that we have may reveal some patterns. We have a chart that lists the diagram, the columns, the rows, and we're going to talk about the total area. In diagram 1, we have one column, 2 rows, and a total area of 2. In diagram 2, we have 2 columns, 3 rows, and a total area of 6. There should be some patterns that are starting to emerge as students begin to fill in the table. At this point, we want to start asking students what patterns they see in the table. And there's a lot of patterns that they may see. We want to hear all of them, but we want to get students to recognize that the columns are always the same as whatever diagram they're on, so that the columns are stage X. One thing students may notice is that there's always one more row than columns. That means that the rows are always one more than X, or X plus 1. Students may also recognize that the area column is just the multiplication of the rows and columns. After all, it's an array that they've built since elementary school, which means that the expression for the area is just our columns, x, times our rows, the quantity, x plus 1. Some students may already distribute and say that this is the square of x plus 1 row of x, or 1x. We're going to come to a better connection to that in just a moment. When we look at this in terms of squares and extra rows, we can actually see that diagram and see that expression. Each time we have a perfect square and one extra row. In stage 4, we have a 4 by 4 square and one row of 4. Same thing in the third diagram. We have a perfect square that's 3 by 3 and an extra row, or an extra linear amount. But let's hide that expression for a moment and let's make a slightly better connection. Let's redo our table, but this time, let's talk about the square size and the row length. We're going to go backwards in this table, which is a little bit unusual, but it becomes helpful later on. Let's start with stage 4. Our square size is 4 by 4, and our row length is 4. At stage 3, we have a 3 by 3 square and a row of 3, a 2 by 2 square and a row of 2, and so on. We can now ask students to predict what will be in stage 5, even though they don't have it drawn. They'll likely predict that it's a 5 by 5 square and a row of 5, which means that for any diagram X, we're always talking about a square of X and an extra row of length X, which connects right back to the distributed version of our original expression. A square and a row, x squared plus 1x. This is an unusual one, but it's another one that's really good to explore. One question that we want to ask students is what is staying the same, and we want to follow it with what is changing. As we go through each stage, what's happening? Students may perceive this in a number of ways. They may talk about the top two and bottom two squares getting further and further apart, and then something growing in the middle. They may have other ways to describe it, but the key is that we want to talk about that the two tiles on top and the two tiles on the bottom are staying the same in every diagram. And what's changing are the tiles in the middle. The moment that we have something that's the same, something that's different, we can start charting these out in meaningful ways. Again, we're going to start with a table that includes our diagram, the size of the square that we're seeing, and the constant or unchanging tiles. Again, we're going to go backwards through the table. It may seem a little unusual, but it will make the patterns easier to see, particularly when we look at stage 1. At stage 4, we had a 3 by 3 square, and we had 4 constant tiles, the 2 on top and the 2 on the bottom. At stage 3, we had a 2 by 2 square and 4 constant tiles. At stage 2, we had a 1 by 1 square and 4 extra tiles. And this is where it's very important. By going backwards, we reveal that the square in stage 1 is actually 0 by 0, because that fits into the pattern that we're already seeing, and that there are 2 or pairs of unchanging or constant tiles. From here, we can ask students to tell us what stage 5 should be. They're likely going to pick up that it's going to be 4 by 4 with a constant unchanging 4 tiles. Now we want to think about any situation. Well, what did we do? When we looked at the diagram, how is that related to the size of the square? We noticed that whether it's 0 by 0 or 3 by 3 or 4 by 4, the numbers for the square are always 1 less than whatever the diagram is. So we're always looking at a square of 1 less than the value of x, and 4 more. That means that the expression to model any diagram that we may come up with is the square of x minus 1 plus 4. I hope that this video helps teachers create classrooms where students explore math, observe patterns, and develop conceptual understanding. If you have questions, comments, or have a video idea, please email me at the address below.